You ever find yourself sitting in an office or maybe a mall and you just kind of look up at the air vent? Yeah, you probably just think, oh, that's the AC, right? Well, what if I told you it's also a key part of this silent, invisible fire protection system? Today, we're going to pull back those ceiling tiles and take a look at the hidden safety systems in the very air you're breathing inside big buildings. And, it all really starts with one single critical question.
This right here, this is the paradox we're going to unpack. The very system that keeps us all comfortable, the HVAC system, it's basically a network of pathways that connects almost every single room. And in a fire, that network can go from a life support system to a deadly delivery service for smoke and flames. So, how do we stop that from happening?
To really understand how we solve this problem, we first need to appreciate just how big of a deal it is. So let's break down this double-edged nature of a building's ventilation system.
Yeah, this slide just lays it out perfectly. On the one hand, the HVAC system is like the building's lungs, right? It's essential, circulating fresh air, keeping us healthy. But, on the other hand, those exact same ducts become superhighways for danger. A fire that starts in one tiny room can have its smoke and superheated gases pushed through the vents, reaching floors way on the other side of the building in just minutes. It's a huge, huge vulnerability.
Okay, so how do engineers possibly tame this powerful two-phase system? Well, they use a rule book, a very specific, life-saving rule book that's designed to turn those dangerous highways into a series of secure checkpoints.
And that rulebook is called NFPA 90A. Now, I know, a safety standard sounds about as exciting as, well, watching paint dry. But trust me, this document is the absolute life-saving playbook that architects and engineers use to design that invisible shield protecting you. Every single rule inside it is a lesson that was learned, often from a tragedy, about how to keep fire and smoke locked down.
And what's really wild is that this isn't some new idea. It's the result of over 100 years of learning. I mean, it goes all the way back to early concerns about simple blower systems in 1899, all the way up to the modern rules for special fire-rated cables that were added in 2009. This standard has been constantly evolving. It learns, it adapts, and it just gets smarter with every new building material and every tough lesson learned.
So what's its mission? Well, it boils down to these 4 critical goals, and this is straight from the standard itself. Number 1, stop smoke from traveling through the ducts. Number 2, stop the fire itself. 3, make sure that wherever a duct has to punch through a fire-rated wall, that wall's strength isn't compromised. And finally, number 4, get rid of anything that could possibly burn inside the system. Every rule we're about to look at serves one of these 4 goals.
All right, so with those goals in mind, let's take a little tour through a properly designed HVAC system and see these rules in action. First up, we need to talk about a space called the plenum. This is basically the hidden world that's above the drop ceiling tiles. And it's not just empty space up there. It's often used as a giant open pathway to return air back to the main HVAC unit. And because air is flowing freely through this whole area, what you put inside it matters a lot.
And that is why NFPA 90A has these incredibly strict rules for everything that goes inside this critical airspace. Materials are literally rated on how fast flames can spread across them and how much smoke they create. Everything from the installation to the coating on electrical wires, it all has to meet a low smoke, low flame standard. Regular old PVC cables? Nope, totally forbidden because they release these awful toxic fumes when they burn. Instead, you need special plenum-rated cables. The standard even makes you remove old abandoned cables because they're just sitting there acting as extra fuel waiting for a spark.
Okay, so we've covered the materials, but what about active protection? I mean, what happens when a duct has to go right through a solid, fire-rated wall, a wall that's specifically designed to stop a fire from spreading?
You install one of these bad boys, a fire damper. The best way to think about it is like an automatic guillotine, a hidden gatekeeper just sitting there inside the ductwork. Its one and only job is to slam shut in a fire, and when it does, it effectively rebuilds that fire-rated wall right through the duct.
And the best part is just how simple it is. There are no complex electronics, no computers. Under normal conditions, air just flows right through it. But during a fire, the hot air flowing through the duct melts this tiny piece of metal. It's called a fusible link. That little link is the only thing holding back a powerful, spring-loaded steel door. So when the link melts, bam, the door slams shut, sealing the duct and containing the fire. It's simple, it's automatic, and it's incredibly effective.
Now, having all this gear is great, but
How do we know it's actually going to work on what could be the absolute worst day of that building's life?
This is so crucial. None of this is just left to chance. Chapter 7 of the standard requires that before anyone even moves into the building, every single one of these dampers gets tested. An inspector physically triggers them to make sure they close just like they're supposed to. This isn't just an installation, it's a verified life safety system.
Okay, let's bring it all home. We've talked about standards, plenums, dampers, all this stuff. But what's the real-world payoff? What does all this invisible engineering actually mean for you?
Well, it means that the system that was built for your comfort won't betray you in a crisis. It means a fire gets contained or compartmentalized, giving everyone in that building precious life-saving minutes to get out safely. It's an entire network of silent automatic guardians. So the next time you look up and you see an air vent, I really hope you see more than just a piece of the heating and cooling system. I hope you see a small part of an invisible, intelligent shield that was engineered and tested just to keep